Okay, this is 11.5 homework. The first problem wants us to find the constant term in this expansion right here. So we're starting the homework without a doubt. Sorry about that. The order is not very helpful with this, but we need to expand this out using the binomial theorem. Now the binomial theorem is on the formula sheet, which is right here under chapter 11. So here's the formula right here. Now what we're going to do is you follow this pattern, and I'll go through this in an easier example and hopefully it'll make more sense, but you start off with 48C0. Turns out that this is Pascal's triangle, the 48th row, so you could actually start off with 48. It's symmetric, so you could go the other way, start off with the highest number here, it doesn't matter, but I'm going to start off with 0 and work my way up. And then it's A, which is the first thing, which in this case is right here. Here's A and here's B. So it's 2x to the 7th raised to the nth power, which is 48, times the second thing, which is 1 over x to the 0th power. Now what you do moving forward to expand this, because obviously you don't want to actually do this to the 48th power, that would be, you'd have to write this out 48 times and that would take you months. So what we're going to do is just follow the binomial theorem, which says that we can lower this exponent by 1 to get for the next term, raise this one by 1, and here I'll do this in a different color, lower that one, raise this one, and raise that number by 1 each time, and moving forward. That's the pattern. So the next term is going to be 48C1, 2x to the 7th raised to the 47th power, and then 1 over x raised to the 1st power, and you follow that pattern. Well, eventually you're going to get a constant term out of that. And this is whether this problem is really hard, and you might want to start with an easier one, and I won't ask you a problem this hard on a test. It's way too difficult. But what you would do is you need to think about how could you get a constant term here? And what you would do is you'd have 2x to the 7th raised to some power, I'm going to call that power y, and you'd have 1 over x raised to then 48 minus y, because these always add to 48, these two numbers. And so basically to get a constant term, I have to have the 7y, the exponent from here, equal to the exponent in the bottom because they need to cancel. For example, if you have x to the 3rd and you multiply by 1 over x cubed, these cancel and you just get the number that's in the numerator. In this case it'd be 1, but that's what we need here. So we need this exponent 7y to be equal to this exponent, which is, there's a 1 right there, times the 48 minus y. So that's what I need. I need 7y to be equal to 48 minus y in order for the variables to cancel and just have a constant term or a number. So I could add y to both sides. I get 8y equals 48. Divide both sides by 8, you get y equals 6. So in order for that to happen, this would need to be a 6 right here. And this would then need to be a 42, 48 minus 6. All right, in that case, what you'd find is that this would be 2 to the 6th x to the 42nd times 1 over x to the 42nd, in which case these would cancel and you just get this number. But I also still have the 48C 6 out front here because, or actually I could do 48C 42. Like I said, it's symmetric, but following this theorem, this starts off at 0 and goes up. So this number always matches this number. So to finish this, I need this number, 48C42, which is going to be a really big number, times 2 to the 6th. That's my number that's out front after the variables cancel. So that's the constant I'm going to have to do in the calculator. So I'm going to pull out the calculator, and I'm going to do 48 math, probability, NCR, 42. That gives me this really big number. I need to multiply that by 2 to the 6th power, which is really just 64. That gives me this number. So there's my answer. And I know it's a really big number, but that should be the answer if I enter that in. Okay, the next problem wants me to not do this whole expansion, but just give me the coefficient that's on that specific term. So here's the formula once again on the formula sheet. So if you start writing this out, you'd have the first term would be 15C 0, 4x to the 0th power, and then 1y to the 15th power, and you'd keep going with that pattern where you'd raise this number, lower this number, raise this, until you get down to what you're looking for, where you have a 12 right here. That needs to be a 12. So that'd be 15C3, 4x to the 12th power and y to the 3rd power then if you follow that pattern of moving this number up and moving this number. And I'm sorry, this should have been a 15 and this should have been a 0. So then you're moving this number down 3 and this up 3 to get to this 3rd term. In which case they want the number, so they want 15C3 in the calculator times 4 to the 12th if I bring that down. And then this is just 1. So that's what I want. I'm going to have to do that in the calculator. 15C3 is 15 math probability C, which is the 3rd one, 3. And then I have to multiply that number by 4 to the 12th. So what I'm looking at is this number. I know it's a really big number again. That number right there. Okay, the next problem wants to find the 4th term in this binomial right here. So if you start filling this out, you can see you have x minus 4y to the 10th as you're comparing here. So a is x, and 10 is n. So you'd have the first term would be 10c0. A is x, like I said, to the nth power, which is 10th power. And then the second term is negative 4y, don't forget the negative, to the 0th. And you'd keep going with that pattern now, once again, where you would lower this one by 1, raise that one by 1, raise that one by 1. Okay, so what the term we're looking for, since this is the first term, you can imagine that then the second term would have a 1 here, third term would have a 2 there, and the fourth term would have a 3 there. So I'm looking for when this is a 3. So I'm just going to go ahead and change this to a 3, in which case this would be 10 minus 3, which is 7. And this number always matches that in the formula. So this would also be a 3. And that's what we're looking for. We need to simplify this though. 10c3, if you do it in your calculator, gives you 120. X to the 7th times, and then negative 4 cubed is negative 64. Y cubed, if you cube both the negative 4 and the y. So then multiply negative 64 times 120, and you get negative 7,680 x to the 7th y cubed. That's your answer. Okay, the next problem wants us to fill this whole thing out. So it wants us to do the whole expansion using the formula. So once again, the formula is right here. If you fill this out, you're going to have, this is going to be 5, so it's going to be 5c0. And I'm going to actually start writing this way down here so I have room. So it's 5c0, and then the first term a is 2x, so it'd be 2x to the nth power, which is the 5th power, and the next one is negative 1, and that's to the 0th power. Now to follow this pattern, all I do is do 5c, raise this one by 1, lower this one by 1, and raise this one by 1. So just follow that same pattern. 5c2, 2x to the 3rd, negative 1 squared, and you get the idea. Let me finish this for you. Now once you get this written out, you do have to simplify it now. So we want to know the 5th row of Pascal's triangle. One easy way to get the 5th row of Pascal's triangle, by the way, is to go to y equals and type in, let me clear this real quick, type in 5 math probability, 3rd one, and put an x there, and then just set your table up. So go to second table set to start at 1 and go by increments of 1. And look at your table, and you'll see the 5th row of Pascal's triangle there actually start at 0 and go up. So it's 1, 5, 10, 10, 5, 1. So what that means is this is 1, this is 5, this is 10, this is 10, this is 5, this is 1. You should look up Pascal's triangle if you haven't already in the notes, and take a look at that row. It's the 5th row of Pascal's triangle, which you can get from the calculator. Now you have to simplify this, so it's 2 to the 5th, which is 32. So this first term becomes 32x to the 5th, and that's just to the 0th. So that's just 1. And the next one is 2 to the 4th, which is 16 times. So that's 80x to the 4th, negative 1 to the first is negative 1, so I have to make this a negative up front. And then plus, now I have 2 to the 3rd, which is 8 times 10 is 80. So this would be 80x to the 3rd. Negative 1 squared is positive 1, so that goes positive. And now the next one is 2x squared times 10. So 2 squared is 4 times 10 is 40. x squared, and then negative 1 to an odd power is still negative 1, so I have to change this to a negative because that negative is going to get multiplied out front. Now the next term here would be 2 times 5, which is 10. X to the first, and then negative 1 to the fourth power goes positive. And the last term is this drops to 1, and negative 1 to the fifth power is just negative 1. So that should be my answer right there. Now they want me to enter this in where they just want the coefficients in front. So my coefficient answers are, 32, negative 80, 80, negative 40, 10, and negative 1. Okay, the next one wants me to do the same thing. So it's 5c0. First term is 4x. That's to the fifth power. Second term is negative 2 to the 0th power. And I follow that pattern where I increase this by 1, lower this by 1, and raise this by 1. So I'll finish filling this out for you. Okay, so now I'm simplifying this. Once again, the fifth row Pascal's triangles 1, 5, 10, 10, 5, 1. And then I need 4 to the fifth times 1. That's 1024. X to the fifth. Negative 2 to the 0th is just 1. Plus now I need 4 to the fourth times 5 times negative 2. That's negative, so I'll make that minus 2560, and then you're still going to have x to the fourth. And now the next one, I have 4 to the third times 10 times negative 2 squared. That's positive 2560. Then you have x to the third. And the next one you have 10 times 4 squared times negative 2 cubed, which is negative 1280. And you have x squared. And the next one you have 4 to the first. Negative 2 to the fourth is positive 16 times 4 times 5, 320. And then the last one, this goes to 1, so you just have negative 2 to the fifth, which is negative 32. So that should be my answer right there, which I think I have to enter that whole thing in, just the coefficients. So 1024 goes here, and so on. Okay, the next one, when you start doing it, it's to the 13th power, so you have 13c0. The first term is negative x, and that'd be raised to the 13th power. And then the next term is negative y, which would be raised to the 0th power. But I want to go down until I get a 5 for x, so this would be a 5. And this would be an 8, in which case this would be an 8. So that's the term I want right there. So I have to simplify that. 13c8 times negative 1 to the fifth is a negative 1, and negative 1 to the 8th is a positive 1. So I'm going to have a negative number. 13c8 gives me 1287. So it'll be x to the fifth, y to the 8th. And they just want the coefficient, so negative 1287. Okay, the next problem gives us this expansion. It wants to know which contains x to the 42. And this is a little confusing because it's got a 6th power there. So if we start filling it out, we get 36c0, x to the 6th raised to the 36th power, 4 raised to the 0th power. Now if you keep going down, the question is, at some point, we're going to have some number here, I'll call it y, and this would obviously be 36 minus y. And we want to know when this is going to be the 42nd. So we would have x to the 6th y have to equal x to the 42, right? Because this would have to be a 42. So 6y would have to be 42. In which case, divide both sides by 6, y would be 7. So that would mean that this would be a 7, in which case this would be 29. Now, if you follow the pet, this would be a 29 as well. So what term number that is, that's the 30th term for me, because if you follow that pattern, when this was a 0 right there, that's the first term right there. So when this is a 0, it's the first term. When this is a 1, it's the second term. So when this is a 29, it's the 30th term. That's a little confusing. It's always one higher for the term number. Hope this helps.